Most portable generators are not wired as single-phase dual voltage. They are typically wired as single-phase 120/240 volts. Because the generator is not wired as single-phase dual voltage, the questions regarding driving a separate ground rod solely for the generator, and whether to connect that ground rod to the pump house ground rod, do not apply. For a single-phase 120/240 volts generator, you would connect the generator's ground terminal to the ground rod for the pump house. You should not connect the generator's ground terminal directly to the utility service ground rod. This is because the generator creates its own separately derived system, and directly connecting to the utility ground can create ground loops and other electrical hazards. A ground loop occurs when there are multiple paths for current to flow to ground, which can lead to unwanted current flow and potential safety issues. In a typical electrical system, the utility company provides the main ground reference. When you connect a generator to your building's electrical system, you need to ensure that the generator's ground and the building's ground are properly bonded to maintain a safe and reliable electrical connection. When using a portable generator to supply power to a pump house, it's crucial to ensure the generator and pump house electrical systems are properly grounded. Grounding provides a low resistance path for fault current to flow back to the source, which helps protect against electrical shock and equipment damage. Here's a breakdown of how to ground a portable generator connected to a pump house electrical system. Firstly, identify the grounding points. Locate the grounding terminal on the portable generator. This is usually a stud or lug labeled with the ground symbol. Locate the grounding electrode system at the pump house. This typically consists of one or more ground rods driven into the earth, connected by a grounding electrode conductor. Secondly, connect the generator to the pump house grounding system. Run a grounding conductor from the grounding terminal on the generator to the grounding electrode system at the pump house. The grounding conductor should be sized according to the generator's output capacity and local electrical codes. Ensure the grounding conductor is securely connected to both the generator's grounding terminal and the pump house grounding electrode system. Thirdly, avoid direct connection to the utility service ground rod. As stated earlier, do not connect the generator's grounding terminal directly to the utility service ground rod. This can create ground loops and other electrical hazards. Instead, connect the generator to the existing grounding electrode system at the pump house. Fourthly, verify grounding integrity. After completing the grounding connections, verify the integrity of the grounding system using a multimeter or ground tester. Measure the resistance between the generator's grounding terminal and the pump house grounding electrode system. The resistance should be as low as possible, ideally less than 5.0 ohms, to ensure effective grounding. Fifthly, check local electrical codes. Always refer to local electrical codes and regulations for specific requirements regarding grounding portable generators. Electrical codes may vary depending on the location and jurisdiction. Sixthly, use appropriate safety measures. When working with electrical equipment, always use appropriate safety measures, including wearing insulated gloves and safety glasses. Disconnect power to the pump house before making any grounding connections. Seventhly, consider using a transfer switch. For permanent or semi-permanent installations, consider using a transfer switch to safely connect the generator to the pump house electrical system. A transfer switch allows you to switch between utility power and generator power without backfeeding into the utility grid. Backfeeding can be dangerous and illegal. Eighthly, understand separately derived systems. A portable generator typically creates a separately derived system. This means that the generator's neutral conductor is not connected to the utility's neutral conductor. This separation helps prevent ground loops and ensures proper operation of ground fault circuit interrupters, often referred to as ground fault circuit interrupters. Ninthly, size the grounding conductor correctly. The size of the grounding conductor must be adequate to safely carry fault current. Refer to the National Electrical Code, often referred to as the NEC Table 250.122 for the minimum size of equipment grounding conductors for grounding raceway and equipment. Tenthly, maintain the grounding system. Regularly inspect and maintain the grounding system to ensure it remains effective. Check for loose connections, corrosion, and damage to the grounding conductors and electrodes. Replace any damaged or deteriorated components promptly. By following these steps, you can ensure that a portable generator connected to a pump house electrical system is properly grounded, protecting against electrical shock and equipment damage. It's essential to prioritize safety and comply with all applicable electrical codes and regulations. In general, when dealing with electrical systems, safety should be the top priority. Grounding plays a critical role in ensuring electrical safety. By following the correct grounding procedures, you can minimize the risk of electrical hazards and protect both people and equipment. Always consult with a qualified electrician if you have any questions or concerns about grounding electrical systems. To elaborate further on the importance of grounding, consider these points. Grounding provides a low impedance path for fault current to flow back to the source. This allows overcurrent protection devices, such as circuit breakers or fuses, to quickly detect and interrupt the fault, preventing electrical shock and equipment damage. Without proper grounding, fault current may flow through unintended paths, such as through a person's body, resulting in severe electrical shock or even death. Grounding also helps to stabilize voltage levels in the electrical system. By providing a reference point for voltage, grounding helps to minimize voltage fluctuations and transients, which can damage sensitive electronic equipment. In addition, grounding helps to reduce electrical noise and interference in the electrical system. By providing a path for unwanted electrical signals to flow to ground, grounding helps to improve the performance and reliability of electronic equipment. It's also essential to understand the difference between grounding and bonding. Grounding refers to connecting electrical equipment to the earth, while bonding refers to connecting different metal parts of the electrical system together to create a low impedance path for fault current. Both grounding and bonding are essential for ensuring electrical safety. Bonding helps to minimize voltage differences between different metal parts of the electrical system, reducing the risk of electrical shock. When connecting a portable generator to a building's electrical system, it's crucial to ensure that the generator's grounding system is properly bonded to the building's grounding system. This helps to create a safe and reliable electrical connection. It's also important to consider the type of grounding system used in the building. There are several different types of grounding systems, including grounded, ungrounded, and impedance-grounded systems. Type of grounding system used will affect the way the generator is connected to the building's electrical system. In a grounded system, the neutral conductor is connected to ground at the service entrance. In an ungrounded system, the neutral conductor is not connected to ground. In an impedance-grounded system, the neutral conductor is connected to ground through a resistor or inductor. When connecting a portable generator to a grounded system, it's essential to ensure that the generator's neutral conductor is also connected to ground. This helps to maintain a stable voltage reference and prevent voltage fluctuations. When connecting a portable generator to an ungrounded system, it's typically not necessary to connect the generator's neutral conductor to ground. However, it's important to ensure that the generator's frame is properly grounded to prevent electrical shock. When connecting a portable generator to an impedance-grounded system, it's essential to follow the manufacturer's instructions carefully. The impedance grounding system may require special grounding connections to ensure proper operation. In addition to grounding and bonding, it's also important to consider the overcurrent protection of the electrical system. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect the electrical system from overloads and short circuits. When connecting a portable generator to a building's electrical system, it's essential to ensure that the generator is protected by appropriate overcurrent protection devices. The size and type of overcurrent protection devices will depend on the size and type of the generator. It's also important to consider the voltage and current ratings of the electrical system. The voltage and current ratings of the generator must be compatible with the voltage and current ratings of the building's electrical system. Connecting a generator with a voltage or current rating that is not compatible with the building's electrical system can damage the generator or the building's electrical system. Finally, it's essential to consult with a qualified electrician before connecting a portable generator to a building's electrical system. A qualified electrician can help you determine the appropriate grounding, bonding, and overcurrent protection requirements for your specific situation. They can also help you ensure that the generator is connected to the building's electrical system safely and properly. Remember, electrical safety is paramount when dealing with portable generators and electrical systems. Always take the necessary precautions to protect yourself and others from electrical hazards.